Thank you for watching my lectures in YouTube, and please subscribe to my channel and support me by subscribing. Okay, let me solve a problem about finding roots and about the convergence and rate of convergence of a sequence. The problem is show that the sequence xn, n from 0 to infinity, which is defined by xn plus 1 equal to 1 half xn plus a over xn, where a is positive and n start from 0 and continue until the infinity, converges to square root of a, and show that the rate, the order of convergence, the order of convergence is 2. This kind of problem has a framework for solving. I will show you the framework so you can solve every problem in this form. Okay, so if you want to solve such problems, first of all you have to let limit of xn when n goes to infinity be equal to x. Okay, so if you take limit from both sides and go and in fact let n goes to infinity, we will have limit xn plus 1 n goes to infinity equal to limit half xn plus a over xn, n goes to infinity. Okay, now so you can put instead of this x, and if you bring limit inside the parentheses, you will have for this limit x and also for this limit x. Okay, so finally you can get in the left hand side x and in the right hand side half and x plus a over x. Okay, now you have to solve this equation and you can solve it easily. It's 2x equal to x plus a over x. It is equal to x squared plus a over x, and this gives x squared plus a equal to 2x squared, and this gives x squared equal to a, and this gives x equal to square root of a. So this is the first part of the problem, and in fact we could show that the sequence in fact converge to square root of a. But for the second part, define or let g of x be 1 over 2 x plus a over x. Okay, so you can define xn plus 1 equal to g of xn. Okay, and we know that square root of a is the fixed point of this sequence, and we know that square root of a is a fixed point for g of x. So in fact we know that g of square root of a is equal to half times square root of a over square root of a, and this is half times square root of a plus square root of a, and this is square root of a. Okay, so in fact maybe it's better I remove this part, and it's much better. In fact I proved that square root of a is a fixed point of g of x. Okay, now we compute g prime of x. Okay, this is equal to half minus half times 1 minus a over x squared, and this gives g prime at radical a at square root of a is half times 1 minus a over a, and it will be 0. What does it mean? It means that the order of convergence is at least 2. Convergence is at least 2. Yeah, it's at least 2. Now we have to prove that the order of convergence is exactly equal to 2. To this end, we have to write the Taylor expansion of g of x at x equal to square root of a. Okay, now we write the Taylor expansion at x equal to square root of a. What do we get? We get g of x equal to g of square root of a plus x minus square root of a squared times g prime at square root of a. Okay, something like this. Some mistake here. I had a minor mistake here. I should remove these two. Okay, so this is g prime of a plus x minus square root of a squared over 2 g double prime at square root of a. Now we know that this is equal to square root of a, and also we know that this is equal to 0. I have computed it here. Okay, this is equal to 0, so this term vanish. Okay, now here I get, and also I know so if I put instead of x xn, okay, so g of xn is equal to square root of a plus xn minus square root of a squared over 2 g double prime at square root of a. Now I have to compute one thing, g double prime at square root of a. Okay, let me compute it. G double prime of x, but g double prime of x is equal to here, look at here, this is in fact 1/2 a over minus 1 half minus 1 half a over x squared. Okay, let me see. Yeah, no, it's 1 half 1 minus a over x squared. Okay, this is, yeah, I have to compute prime of it. So it is 1 half a over x squared minus prime, and it is minus a over 2 times 2 over x to power of 3. Okay, and this is in fact minus a over x to power of 3, and it will be a minus maybe appear here, and finally it should be a plus. Okay, so if you compute g double prime at square root of a, it will be a over a square root of a, and it is 1 over square root of a, and this is not equal to 0. Okay, so I can put here 1 over square root of a, and here I have this one. So finally I get xn plus 1 equal to square root of a plus x minus square root of a xn square root of a over 2 times 1 over square root of a. Okay, move square root of a to the left hand side, so I will get xn plus 1 minus square root of a equal to xn minus square root of a squared over 2 times 1 over square root of a. Now consider this one en plus 1 and this one en. Okay, so it gives en plus 1 equal to en squared over 2 times 1 over square root of a. Divide both sides by en, so we get en plus 1 over en squared is equal to 1 over 2 square root of a. Okay, and this gives limit en over en plus 1 squared n goes to infinity is less or equal 1 over 2 square root of a, and by the definition of the order of convergence, it gives that the order of convergence is 2. Okay, exactly this number, these 2. So this is a typical example about the order of convergence. I will solve one more problem about this kind of problems in the next lecture. Please subscribe my channel and wait for the next lecture.